Alright, ladies and gentlemen, in today's video we're going to be discussing compound inequalities. Typically speaking, there are two compound inequalities. There is an OR compound inequality and there's an AND compound inequality. Now, an OR compound inequality generally says the set of solutions is going to be this set of numbers or this set of numbers, with something excluded in between. An AND compound inequality typically is going to say it's going to be this set of numbers and this set of numbers, where the two sets should overlap each other, generally speaking. So what we're going to be looking at here is how do we solve them and how do they look on a number line. In this example, we have an OR compound inequality, where on the left side we have one inequality and on the other side we have another inequality. Now I'm going to be frank and say that this example is not my favorite example because it generally doesn't look like what an OR compound inequality generally looks like. Let's go ahead and work it out and see what we get. So we're going to treat each inequality just like any other normal linear inequality. We'll solve for our variable and see what we get. So distribute the -3 into the parentheses and just continue to solve for x. So get rid of the 6 here, move the constant term from the left side to the right side, and that'll give me -3x to be greater than 21. Now at this point, we're going to divide both sides by -3, the coefficient, in order to get our variable by itself. Now the one thing that you do have to pay attention to is because we're dividing across an inequality symbol, the inequality symbol has to change directions. So -3 over -3 simplifies to be 1x. 21 over -3 simplifies to be a -7. Now let's look at the second portion of the compound inequality. Much less in the way of steps to do here. Get rid of the constant term by adding by adding 3 to both sides. Here they cancel out and create 0. -1 plus 3 produces a 2, and I'm left with x to be less than or equal to a positive 2. Now the reason why this isn't my favorite example is going to be evident here, especially when we look at it on a number line. So we're not going to draw this to scale at all. Let's just say that this point right here is -7, and let's say that this point right here is the positive 2. So according to the inequality symbols that we have, for where it says x is less than -7, well, if x is less than -7, that inequality symbol says to use a curved bracket. And because x is less than -7, we're going to curve it in the direction that x will go. Since x is less than -7, from the -7 on the number line, it's going to go to the left. Now let's look at the second portion of our compound inequality. X is less than or equal to a positive 2. Because of the inequality symbol having the equal to component for it, that tells you to use a curved bracket, a square bracket. And because x is less than 2, we're going to curve it, or we're going to shape it in the direction that x is going to go. So x is less than or equal to the positive 2. So from 2 on the number line, it's also going to go to the left, which is basically saying we have an OR compound inequality where they overlap each other. And I don't always like seeing that because generally speaking, we don't see OR compound inequalities that produce a number line that looks like this. Now we didn't make any mistake in the math and we graphed it correctly, but I just don't like the way it looks. So what I'd like to do is, instead of just looking at this one, I would like to produce a second example that is more typical of what you will see with an OR compound inequality. So copy this other example down, -3x minus 1 to be less than -4, or 4x plus 3 to be less than -6. And solve each inequality for its respective variable again. Begin by getting rid of the constants. So here, negative 4 plus 1 will give me a negative 3. These cancel out, so I'd be left with negative 3x to be less than negative 3. Divide by the coefficient, negative 3. When I divide with a negative number, the symbol must change directions. So for the inequality on the left, we wind up with x to be greater than positive 1. So now let's take a look at the inequality on the right. Again, remove the constant term and divide by the coefficient to isolate your variable. So 4 divided by 4 simplifies to be 1x. Because I'm dividing with a positive number this time, the inequality symbol doesn't change, even though we wind up with a negative sign on the other side. So let's take a look at these numbers. So let's just say that positive 1 is right here, and negative 9 and 9 over 4 is, let's just say that it's right here. Negative 9 over 4, let's just say it's right here. We're not going to make the number line to scale. So on the inequality on the left, we're going to say x has to be greater than positive 1. Because of the inequality symbol, we use the curved bracket, and we're going to curve it in the direction that x will go. Since x from the positive 1 has to go to the right to indicate that it's greater than 1, we're going to curve the bracket in that direction. Same thing with the negative 9/4. Because x has to be less than that negative number, that means from the negative number it's going to go to the left, because that's where the numbers that are less than that are. And again, because of the inequality symbol, we'll use a curved bracket in the direction that x goes. And this is what you see here in the middle. This is stuff that is typically not used. It's excluded from an OR solution set. And this is generally much more in line with what you will see as a solution, especially on the number line, for an OR compound inequality. And that's why I wanted to show it to you, because it's going to, generally they go in opposite directions without overlap. I'm not saying that they can't have overlap, but usually you're not going to see it that way. So moving on to the second type of compound inequality is the AND inequality. Typically, these are going to, they have to satisfy both inequalities to begin with. And typically, we are going to have something that overlaps something else. Now pay attention, there are unique cases where there are no overlap. So if there is no overlap, in this case, we would have no solution, an empty set. So let's take a look at this one here. The inequality on the left does have fractions on it, so you're more than welcome to multiply with a common denominator of 6 if you would like, but it's not necessary. So I'm going to begin by moving the constant from the left side to the right side. Here on the left, they're opposites and cancel, and I get positive 5 over 6 here. So 2/3 x is less than or equal to 5 over 6. To get rid of the coefficient of 2/3, multiply by the reciprocal, and on the left side, the 3 over the 3 simplifies to be 1, the 2 over the 2 simplifies to be 1, so that just leaves me with 1x. And because I'm multiplying with a positive number, the inequality symbol won't change directions. Now on the right side, when we multiply in fractions, we multiply tops together and bottoms together. So the 5 times the 3 gives me 15. The 6 over the 2, or the 6 and the 2, gives me a 12. So I wind up with a fraction of 15 over 12, which would just simplify to be 5 over 4. So now that we've solved one of the inequalities, let's take a look at the second one. Now this one is much simpler in terms of operations. There's only one thing that we have to do. Divide by the coefficient -3 on both sides. So -3 over -3 simplifies to be 1x. Because we divided with a negative term, the inequality symbol must change direction, and negative 2 over negative 3 simplifies to be a positive 2/3. So let's go ahead and graph these. And again, we're not going to necessarily, put them in proper scale. So let's just say that 2/3 is right here. So this is 2/3, and 5 over 4, let's say it's right here, 5 over 4. So the inequality on the left says x has to be less than or equal to 5 over 4. So let's go to the 5 over 4. The inequality symbol says to use a square bracket, and because x is less than that number, I'm going to open it in the direction that x has to go, which would be this way. So looking at the inequality on the right, where it says x is greater than 2/3, since x is greater than 2/3, we use the curved bracket, and we open it in the direction that x has to go. Since x has to be greater than 2/3, it's going to go that way. And you can see clearly how they overlap. So it's going to go from the from the right here at 5/4 to the left until it hits the 2/3 and stop. Or vice versa, it's going to go from the 2/3 to the right until it hits the 5/4 and stops. Generally speaking, for an and compound inequality, that's what it's going to look like, where we have two sets that overlap each other. Now, here, for certain types of compound inequalities, they can be written together as one statement rather than separately, as we have seen in the other examples. Now, the one thing that we definitely want to make sure we're paying attention to is this statement right here. Any operation you do in the middle of your inequality must also be done to the left and the right side. And that'll make sense here in just a second when you see what the problem looks like. So in the middle, we have 3x minus 4. On the right, we're saying that it's going to be less than or equal to a positive 19. And to the left, we're going to say that it has to be greater than a positive 2. Now, either of these inequalities could be written separately, but we've combined it together in one term because mathematicians like to be efficient. Now, we were going to solve this just like any other inequality. We're going to get rid of the constant term by adding its opposite, plus 4. But we also have to do it to the right side of the inequality and to the left side of the inequality. So on here, the 2 plus 4, that'll give me a 6. Here in the middle, negative 4 and positive 4 cancel. And here on the right, 19 plus 4 is going to give me a positive 23. So when we rewrite it, we're going to have 6, which is less than 3x, which is less than or equal to 23. At this point, we're going to divide by the coefficient 3 to both sides of the inequality statement. In the middle, the 3 over the 3 simplifies to be 1x. And because we're dividing with a positive number, the symbols do not have to change direction. So 6 over 3, that's just 2. 23 over 3, unfortunately, doesn't simplify. So we'll just leave it as 23 over 3, something a little bit larger than 7. Now, when we read this, it really helps to read it from the middle to the right and to the left. So if we start in the middle, looking at the x, reading it to the right, we would say x has to be less than or equal to 23 over 3. And when we read it from the middle to the left, we would say x has to be greater than 2. So let's put those numbers on a number line. So here, let's just say that this is 2. And let's just say about here is 23 over 3. According to the inequality symbols, here I'm going to have a square bracket, and at the 2, I'm going to have a curved bracket. Since x is greater than 2, from the 2, we're going to go to the right, which is why we open the bracket going in the direction that x is going to be greater than. Same thing at the 23/3. Since x has to be less than that, we open the square bracket in the direction that x has to go. So one goes this way, while the other one goes this way. And once they get to their respective other sides, they simply stop because x can't proceed past either of those two numbers. So here is a compound inequality, an AND compound inequality, written as one statement where we're still doing the same operations. We just are doing it in a little bit more efficient manner by writing them out as one statement rather than two separate ones. So last example, another compound inequality. Begin by removing the constant in the middle, but we want to subtract 1.4 instead of adding. So minus 1.4, minus 1.4, and minus 1.4. So on the far left side, that's going to give me a negative 9.6. In the middle, those two terms cancel and produce a 0. And here, this is going to give me a negative 2.3. So rewrite the problem with what we've changed. We got a negative 9.6 to be less than negative x, which is less than negative 2.3. At this point, we're really dividing by a negative 1 in order to get a positive x by itself. Because I'm dividing by a negative sign, or by a negative number I should say, the inequality symbols must change directions. So I have a positive x in the middle of it, and I'll have a positive 2.3 on the right, and a positive 9.6 on the left. Now again, when you read it from the center to the left or the right. If we read it from the center, starting with the x, to the left, we would say x is less than 9.6. If we read it to the right, we would say x is greater than 2.3. So again, we're not going to draw this to any kind of scale. Let's just say 2.3 is right here. And over here, let's say 9.6. So when we graph it, the inequality symbols both are using a curved bracket where x is greater than the 2.3, so we curve it in the direction that it'll go, and x is less than the 9.6, so we also curve that in the direction that it'll go. And we can see the solution set is all of the numbers contained in between the 9.6 and the 2.3. And that's really how we graph compound inequalities. We can write them separately, we can keep them together. Typically, they'll be going in opposite directions for an OR and overlapping for an AND, but the algebra steps that we use don't really change. So thanks for watching. Make sure you take good notes and come see me if you have any questions.